is Irvin Ulises Sanchez Rangel. I'm here to present my project during these professional practices. The topic of my project was coordination of protection, short circuit, electrical studies, and optical current transformers. This was made in a company named Epson. For project description, we can mention two topics. The first one being the development of different tests, such as short circuit, electric car, and coordination of protections. This was especially made for a company that requested the services of Epson. The other one is the research and investigation of optical current transformers. This was made so future engineers could approach these new technologies and take advantage of these technologies. During these professional practices, we have three main goals. The first one being the development of the test required by the client. In this case, during my professional practices, we had one client, in this case La Morena, a Mexican enterprise specialized in chili peppers. Once we have all the data requested, we need to make a report so the enterprise that requests the test could know the results, as well as some observation for security and some observations so the company could have a better performance as well as improve their electrical grid. The final and last goal is the research about optical current transformers and present to the company, in this case Epson, the advantages that this new technology have against conventional transformers. For specification and regulation, first in specifications, we need to assure a better performance for the enterprise. This is for the case when something external of the company or of the enterprise happens, like a short circuit. Also, we need to assure a safer and reliable workspace for all the employees inside that company. All of these have certain regulations, and those regulations, some of them are shown here. The first one, the IEEE 141, it's the recommended practice for electrical power distribution for industrial plants. The second one is a standard rating structure for AC high voltage circuit breakers. And the third one is a standard and emergency low current carrying capability. Next, we will mention some contributions. And in this case, because our project was developed in two separate topics, we will start first with the project in La Morena. The first project in La Morena, we needed to obtain all the characteristics that the physical plant had. So we can obtain different values of the components in the power systems. This was made in two different locations. The first one being La Morena, Cuamantla, and the second one is La Morena, Lara Grajales. In both cases, the process was the same. First, we need to know the characteristics of all the load centers. A load center is something like this, where you can see all the switches that control all the different machinery, all the lighting, all the things inside a plant. So in both Lara Grajales and Huamantla, we enter the plant and start checking these load centers. So we could obtain the different characteristics of the switches. The switches we needed to know the interruption current, the current they can support, and also their voltage. For loads, in this case, because the client, La Morena, only want a short circuit test, we only consider non-static loads. For example, motors, generators, and machinery heavy machinery that is occupied inside the plant. For those cases, in loads, we always needed to find the power consumption and the voltage in all of the loads. Next, we need some variables for the cables. Those were two principal variables, the first one being the diameter and the second one the length. So we can obtain an approach of a real electrical grid during our simulation and obtain similar values in our simulation that could help obtain a better performance for the company. And finally, transformers, when we need to obtain the material core, their voltages, their latitude, and also their refrigeration system. Once we have those values, we simulate those components in ETAP. ETAP is a software specialized in power systems. And once we have all the electrical grid, all the load centers is simulated in ETAP, we now can proceed to create a short circuit test. This was easier thanks to ETAP that helped us obtain the short circuit in just minutes than doing it by hand and taking many days to do it. The first result we have is short circuit voltages. These are the voltages represented here and are like the voltage gallery in a bus. In this case, a bus represents the load centers we previously mentioned. So in this case, we can see that the voltages are gathered in these load centers, and for the company to assure a safer workspace, we need to dimension our load centers to specific this voltage, so we can obtain a secure and safer workspace. Once we have the short circuit voltages, the next thing we obtain are short circuit currents. These currents are represented here, and you can see also the direction they are going to go. These currents represent the maximum current that happens during a short circuit. In this case, you can see the current in each branch, so you can imagine how your components will behave depending on this current. This is important information for the company, so you can dimension your switches to support higher currents that can prevent your machinery or your lining for a short circuit or even damaging the components inside the machinery. Our next part of the project was optical current transformers, and in this case we did some research about their response in different tests. We found 4 different tests, the first one being a steady state response. This was made with two different current transformers, the first one being a magnetic and the second one being an optical current transformer. Both were configured at the same configuration. The optical was configured at 1000 amperes at the primary side, and in secondary side we received 1 volt, and the magnetic in a similar configuration, but it was configured so every 1600 amperes we obtain 1 volt at the secondary side. This configuration was made so we can obtain the next response. The test that was made in this case was linear and saturation effect, and as we can see we have two graphs. The black one being the optical current transformer and the blue one being the magnetic current transformer. The optical current transformer, as we can see, has a very linear behavior, but magnetical current transformer had after a time, after a certain value of voltage of current, we obtained some differences and we started getting some saturation effects. In this case, both were put in the same test with the same values at the same characteristics, and as we can see, the optical current transformers behaves better than the magnetic, proving that the optical current transformer have a better response than a magnetic current transformer. The next test we found was a transient state response. Again, both current transformers were put in the same configuration, and the configuration was the same as the last test. And in this case, we inject a current reaching the limits of the configuration, so we can see how the sensor of the current transformer behaves against this response. As we can see in both graphs, there's a huge difference between these two. The first one, we can see that the current only reaches 600 amperes against almost 6,000 amperes. So in transient state response, optical current transformer had a better response, where we can see that it reaches above its limit, and also it can handle much more current than a conventional current transformer. And the last two tests were made especially just for an optical current transformer. The first one being the step response, so we can see how our system or our optical current transformer behaves against a step response. In this case, here is the graph, and you can see that the step response have a 40 microseconds delay. But in this case, we can see that it's not much of a difference. It's really a small time of difference between the step response and the response the optical current have. And finally, the last test was temperature. In this case, the temperature is known for conflicting against Faraday's effect. In this case, optical current transformers function with Faraday's effect. So temperature is a huge point against optical current transformer. But as we can see, if we increase the temperature, we can see that optical current transformers and a conventional current transformers behaves the same. So we can mention that manufacturers of optical current transformers have this problem in mind and have a response against this type of problem. Finally, the learnings I made during these professional practices were four. The first one, I understand more about power system characteristics and their components these power systems need. The second one being in real life electrical grid. In this case, I was never able to see an electrical grid with my own eyes. This was the first time I approached to electrical grid and saw how it behaves in real life and how people need to interact with this electrical grid, because these are not safe places for people to touch. The next one being the norms some company must follow to achieve a safe and reliable grid. This is really important because at first, as I was growing as an engineer, I wasn't informed about the norms, the multiple norms a company must follow. In this case, I found a lot of forms for short circuit test, for arc test, for coordination and protection, and also for all the protections that are inside the electrical grid. And the last learning I did was new information about new technologies for power system, especially because I wasn't really that close to power systems after I entered this company, and in this company I started learning more about the conventional technologies that were used before, and the new technologies that are approaching and are safer and more reliable to use during this type of system, because you can handle more power than you did with a conventional. Finally, in conclusion, for this test, for these professional practices, we developed both two projects. The first one being La Morena, and in that case, after we completed all the tests, all the short circuit tests, all the electrical grids, all the blueprints we needed to give to the client, we give them also a report where we specified both their electrical grids, their short circuit voltages, short circuit currents, and also some observations we saw during the visiting to their enterprise. And also we did some investigation and some research that could help improve the technologies inside the company I work for, in this case Epsol, so they can improve their tech response, a better measuring for all their future clients. Thank you for your attention.